In today's lesson on exponents, we're going to have a look at simplifying exponential expressions when we have multiplication and division. To be able to simplify exponential expressions successfully, you need to know your laws very well, and you need to understand that your laws can work in both directions. For example, sometimes you will have something like 2 to the power of x times 2 to the power of y, which you would rewrite as 2 to the power of x plus y. In other instances, you will be given 2 to the power of x plus y, and you will rewrite it giving each exponent their own base. Then you also need to remember a few things about the base number. The base number can always be rewritten. For example, if you have 8 to the power of x, you can rewrite it as 2 to the power of 3 to the power of x. But there are some simplifications that cannot happen in the base number. For example, you can never multiply the following two bases. If you have 2 to the power of x times 3 to the power of y, you cannot now multiply the bases and make it 6x to the power of x plus y. That is not true. Similarly, when you have division of, for example, 16 to the power of x divided by 4 to the power of y, you cannot divide and say 16 divided by 4 is 4 and then subtract the exponent. That is once again not true. Let's have a look at a few examples. When you need to simplify an exponential expression that only has multiplication and division, you always start off by rewriting the base numbers as prime numbers. So in our first example, I'm going to start by changing 4 to 2 to the power of 2, 16 to 2 to the power of 4, and in the denominator, the 8 becomes 2 to the power of 3. Now I'm going to use a few of the exponential laws to simplify. So to get rid of the first bracket, I'm going to multiply the exponent, so it's going to become 2 to the power of 4n. Similarly, for the next one, I'm going to multiply the exponents, but now remember that the 4 needs to be multiplied with every term in that exponent. So it becomes to the power of 4n plus 4. And in my denominator, same thing will happen, so it will be 3n minus 3. Now I'm first going to simplify the numerator, and for this I'm going to keep the base at 2, because the first law says if I have the same base, I keep that base and I simply add my exponents. So I'm going to have 4n plus the 4n plus 4. And that has to be divided by 2 to the power of 3n minus 3. So now when I simplify my exponent, I have 8n plus 4, and that is now divided by 2 to the power of 3n minus 3. So when I now want to divide these same bases, the base once again stays the same. I'm going to take the top exponent and I'm going to subtract the bottom exponent. And now I'm going to simplify that, so it becomes 8n plus 4 minus 3n plus 3. So the denominator's exponent simply changes sign. And now I simplify the exponent, so I have 5n plus 7, because I've added those like terms. For our second example, we'll follow the same steps. We'll just have more than one type of base. So I'm going to start off changing the 10 into prime numbers, which means it will be 2 times 5 to the power of n. 25 will be 5 squared. 5 is already a prime number, and 50 becomes 2 times 5 to the power of 2 to the power of n minus 1. Now I'm going to use a whole lot of the different exponential laws. So the first law I'm going to use will be to move the n to both bases, so it will be 2 to the power of n and 5 to the power of n. Next up, I'm going to use the law where I have to multiply the 2 with the n plus 1. So it will be 5 to the power of 2n plus 2. the bottom I already have 5 to the power of n, and now it becomes 2 to the power of n minus 1 and 5 to the power of 2n minus 2. Now I'm going to simplify the top and the bottom separately first. So in my numerator, I'm going to simplify the base of 5 by adding those exponents. So it becomes 3n plus 2. And the same thing will happen at the bottom. So I'm going to keep the base of 2. And then the base of 5, I'm going to add my exponents again. So it becomes 3n minus 2. Now I'm going to focus on the base of 2 and the base of 5 separately. So I'm going to start off with the base of 2. And now I'm dividing. So I'm going to take the top exponent and subtract the bottom exponent. I'm going to do the same for the base of 5. I'm going to take the top exponent and subtract the bottom exponent. So when I now simplify, I will have n minus n plus 1, and then 5 will be to the power of 3n plus 2 minus 3n plus another 2. And when I now simplify, I'll end with 2 to the power of 1 and 5 to the power of 4. So I'll have 2 times 625, which is 1250.